talking more about the whole white pricing we did using the neural network.
Which
So,
project is that for again?
it's financial equations. I forget which number.
11.
11. And
Go ahead.
just to talk about some more our starting points and the goals that we had. So over the summer, we were applying into like the Black-Scholes model and how we could use artificial neural network for it. But now we wanted to use a new financial model and something that's a little bit more difficult than before. So we end up picking the whole white one-factor model. And coming out of the summer, we still had a little bit of limited coding experience. I took a couple CS courses over summer and wanted to be able to apply more of that into what we were doing, especially focusing on Python and cleaning the data and potentially some of the more detailed work with the artificial neural network. And then one end up using some of the swaption data to predict the prices for the whole white model. And to do this, we had to read more articles and papers to understand like what was happening behind the model and some of the math. So in terms of the whole white model itself, it's really focusing on the short-term interest rate and how it changes over time, where R is the short-term interest rate and theta T is the function of time determining the average direction in which that interest rate actually moves.
Tell me a little bit about this whole white model. What is it? How is it useful?
It's important to see how like it like over time that interest rate changes and that impacts how like the different prices changes as well. And like there's different like variables that affect that and like and how it might actually change the price. And that interest rate is actually directly related to like especially focusing on like the zero coupon yield in the market. And then like other parameters, the important ones I believe was the alpha, which is a mean reversion rate, and which is just how like the long-term average for the price. And then we also have like the standard deviation or the volatility of the short rate, and which also impacts how much the short rate actually changes.
So
And
basically,
then,
it's a model to clear. It's a model basically. It's a model future interest rates, right?
yeah,
Still in use. It is still in use today, actually.
Yeah. And so in the beginning, we actually did some simulations comparing it to what the short rate actually, like the interest rate actually was over the last 4 years. And on the right, that's an actual like graph and change of the short-term interest rate. And there's like couple, the main parameters was focusing on the mean reversion rate and volatility. And there's a couple of ways of actually calibrating the whole white and different like the couple strategies, whether it's like focusing only on the mean reversion or focusing only on volatility or trying to change both at the same time. And in terms of this simulation, we kept the mean reversion the same and then changed the volatility to see how we could get the graph to the left similar to the one on the right. And we were able to get like a similar shape, but some of the like values for the interest rate was a little bit off. So we had to do a little bit more research and get a little more detail about like why this is happening. So in terms of the actual code, we made a function and a method to understand what to show the path of the interest rate. And we really only wanted to focus on one of them to really compare like the details of it. And then we wanted to apply the whole white to the swaptions, and swaps are like the derivatives for like exchanging the values of the asset between two financial instruments. And in this scenario, we kept the volatility the same.
Talk to me about when you mean what are you trying to achieve in terms of calibration? What's the purpose here?
We wanted to be able to predict the prices at the end using like the different parameters, and that's what the like calibration is. It's like it being able to predict that price by changing the variables.
And how are you using Python to do that?
Well,
because the model already exists, right? So
yeah. Well, I didn't really get a chance to apply like the artificial neural networks to it yet. because of like how much like math and like detail that goes behind the whole white model, and truly trying to understand it this semester. So we're just trying to understand like how much like the parameters actually change and like the implied volatility of like the swaptions. And we're just trying to understand it by comparing like it's different like time maturities. Like the one on the left shows like 6-month maturity, and then the other one shows like the 10-year maturity. And we're able to see like, because like the smaller the mean reversion actually gets, there's appears to be a higher volatility, especially for the 10-year one when there's -4%. Like the implied volatility actually kept increasing over time, and like that means there's a bigger impact on how the price actually changes. And some of the challenges that we've had this semester was really just the lack of coding experience. So what I did was I try to find the different like resources and websites to keep practicing that coding, and then also understanding the math behind the model, because without understanding the math, you can't really apply like an artificial neural network to it. And then I also tried like creating my own like swaption data and really trying to apply different methods and try to connect it to neural network, but I had trouble with the code as well, especially with like some bugs and errors. So so today, just overall, I learned more about the model and its properties and what the parameters did, including like improving on that Python skills, and just hopefully eventually being able to like actually apply the artificial neural network to the model itself.
Did you learn any of this in your current coursework?
No, I haven't taken any classes regarding like whole white model. I think
Yeah, I don't think you will.
yeah, because in terms of like the Black-Scholes model I did over summer, I just learned it in one of my finance classes. So it's all out. This is like really new.
Yeah, well, that is the idea, right? What you want to do is you want to get involved in projects that have nothing to do with your curriculum, so that you learn two things. Of course, it's more challenging, right? Because you're struggling because you don't know the math. You don't have the Python skills. You didn't know what Black-Scholes is all about, right? But if you're that kind of student, then you could combine both. And then when you graduate, then you got both, right? You got the knowledge that, and don't forget that knowledge that you're getting from Arium, right, is real knowledge because the guy is out there using it in real life.
Yeah, so just some of the things that I like actually learned over this semester is just there's unexpected errors that occur like when coding, so it just takes time and practice to really understand what went wrong. And this semester actually we knew what direction we were going in, but we didn't know the process or like the steps we needed to take to get there. So that's why we needed to like talk to Harry and more to understand, like to give us like some guidance on what to do, and just really being able to like take that initiative to like ask questions and really like know what's going on.
Okay.